Hello and welcome to T Academy. In today's lecture, we'll try to understand rectifying operation. So a simple rectifying circuit with a resistive load looks something like this. We have a supply voltage in series with a diode and then connected to a resistive load R. Let's say the current through the circuit is I and the drop across the resistance is Vd. Let's try to understand how this circuit works. We know that when the diode is forward biased, that is when Vs is greater than Vd, when this voltage will be greater than the load voltage, then the diode will be forward biased and it will conduct in the forward direction. So in this case, the circuit can be drawn like this: Vs in series with the resistance R, and all of the voltage Vs will appear across the resistance Vd, and thus Vs is equal to Vd in this case. So we are assuming an ideal diode where in forward bias condition the drop across the diode is equal to 0. It behaves like a perfect short circuit. Now when the supply voltage becomes less than the load voltage, in this case the diode becomes reverse biased and does not conduct. Thus the circuit becomes open and there is no connection between the output resistance and the source voltage. Therefore, the load voltage Vd becomes equal to 0. However, in this case, when the diode is reverse biased, all of the supply voltage Vs appears across its terminal. Therefore, the diode voltage in reverse bias condition is equal to the supply voltage. Therefore, while designing electronic circuits, the reverse voltage is a critical parameter which has to be taken into consideration. Now let's look at the plot of all these currents and voltages. The first one that I will draw is the supply voltage Vs, which is a perfect sinusoidal signal, something like this. This is Vs versus T. The load voltage Vd will equal to Vs as long as Vs is greater than 0. So during the positive half cycle, Vd will equal Vs, and during the negative half cycle, Vd will be equal to 0. So this is the voltage across the resistance R. Now the current I in forward bias condition is simply equal to Vd divided by R. Therefore, it will just be scaled relative to this voltage across the resistance. It will have the same shape. So this is the current, which also exists only during the positive half cycle and is 0 in the negative half cycle. And lastly, we want to look at the voltage across the diode. So during forward biased, we have assumed the diode to be ideal. So the voltage across it is 0 till the 0 crossing. While during the negative half cycle, the diode must be able to withstand all of the supply voltage. So this gives a brief overview of how a basic resistive rectifying circuit looks like. In the next video, we'll spice up the things a bit by adding an inductor in series with the resistance R and see how the plots change. So see you in the next lecture. Bye.